Hello, everyone, and welcome again to your channel of Math Made Easy. In today's session, I am planning to continue with the reflection, but this one would be an advanced topic. Last time, we learned how to reflect a point about a line or a line about a line. They were pretty straightforward. Today, as I told you before, I'm trying to reflect um, a like one type of conic section about a line and see how we can do that. So reflection, and let's say reflect the conic section. Let's say y equals 2 times x minus 3 square plus 5. So that's a parabola. We know that's a parabola that has its axis of symmetry is in the y-axis at x equals 3, right? And it's opening up. And we want to reflect that over or about line y equals, say, 3x minus 2 or something. Okay, so the line looks something like that. I'm not going to scale. I don't want to waste time. So just get an idea. Here is my x. Here is my y. Let's say this is the -2. And it's going 3. So at 1, it's at 1, 1 and 1, something like here. And this is the line. Y equals 3x minus 2. Again, the vertex of the parabola is somewhere here, 3 and 5, 3 and 5, and it doesn't matter where it is, but basically the idea, we are going to do that over 5 steps. Okay, listen to me carefully and see what we are going to do. I'm going to raise the line as well as the parabola 2 units up. Why 2 units up? Because I want this line to pass through the origin. And you will see why in a second I'm trying to do that. So mathematically, I want to raise that line 2 units up. But by doing that, I'm raising really everything 2 units up. Then, once it's here, I'm going to rotate the line through an angle whose tangent is 3 so that it becomes horizontal. In fact, I want to make this line the x-axis. So I'm moving it up 2 units and then I'm rotating it. But I'm not going to rotate the line because I have an equation. So basically, we are rotating the axis counterclockwise. So even though it's clockwise, you saw that in the rotation, right? So if I rotate a point, I rotate it either clockwise or counterclockwise. But if it's a line or ellipse or any other conic section, I rotate it backwards. So step number 2, I'm going to rotate this clockwise, but the equation counterclockwise through an angle whose tangent is 3, right? Then I'm going to flip it over, reflect it. So the y, instead of being positive, I would make it a negative y instead of a positive y. After I inverted that, I'm going to rotate it back counterclockwise and then move it, counterclockwise and then bring it down 2 units because originally I raised it. So 5 steps: raise, rotate, reflect, rotate, and bring down. So let's see, step number 1 is so easy. Step number 1, I'm going to raise everything by 2 units, meaning I say y minus 2 equals 2 times x minus 3 squared plus 5. Many people will say, why didn't you make the 5, 7? Yeah, you could do that. But if you remember what we did with the, okay, I'm sorry. What we did in the graph transformation, with it something, go review it and you understand why I did that. And then I'm going to move the 2 to the right and expand this parenthesis. So I will get y equals 2 times, that would be x squared, so 2x squared, negative 6x, but times 2, it would be negative 12x, plus 9 times 2 is 18, 18 and 5, 23, and I brought the 2, it's 25. Right? This is the equation. So that's step number 1. Let's write this as step number 1. Let's move to step number 2. Step number 2, I'm going to rotate clockwise, not counterclockwise. I'm sorry, counterclockwise, not clockwise. I want to rotate this line clockwise, meaning I'm going to change the x and the y as if I'm rotating counterclockwise, because I'm going to rotate the axes, so to speak. So I'm going to say x prime, even though I'm not going to use the prime. I didn't use a prime here, just for simplicity. It's less cumbersome. So I would say x bar. Notice that this slope is 1 to 3, right? So the hypotenuse is root 10. So now if I want to, the cosine of this angle is what? 1 over root 10, and the sine is 3 over root 10. So I'm going to say 1 over root 10 x. And now I'm rotating counterclockwise, so it would be minus 3 over root 10 y. And the y prime would be 3 over root 10 x plus 1 over root 10 y. Now I'm going to substitute here. So the y, I'm assuming it's y prime. As I said, I don't like to use the primes. It's confusing. So I'm going to say the y becomes that. So the left-hand side is 3 over root 10x plus 1 over root 10y equals 2 times 1 over root 10x minus 3 over root 10y, quantity square, minus 12 times 1 over root 10x minus 3 over root 10y plus 25. Let's expand the right-hand side. Square of this is 1/10 times 2 is 2/10 or 1/5. So 1/5 x squared. Then the middle term is negative 6 over 10 xy. Negative 6 over 10 is negative 3/5 times 2 is negative 6/5 xy. The third term is 9/10 times 2 is 9/5. So plus 9/5 y squared. So I have a term in x squared, a term in xy, a term in y squared. Then I have negative 12 over root 10x plus 36 over root 10y plus 25. Okay? I can move this here. Let's do it on a single step, because in step number 3, the y would be changed into negative y. So I'm going to say, I'm going to assume this is the right-hand side, and then I will say equals 0. So 1/5 x squared. The y would become negative y, so this becomes plus 6/5 xy. The y becomes negative y, but when you square it, it becomes positive y squared, so it doesn't change. Negative 12 doesn't change, but I have a positive 3. When it comes here, it will come as a negative 3, so I will end up with negative 15 over root 10x. The y would become negative y, so that would be, did we? I'm sorry, I think I did something. No, it's correct. Yeah, this is negative 12, and the x becomes this minus that. Okay, so this becomes negative 36y. Notice this y also would be negative 1 over root 10, but when it moves to the other side, it moves as a positive 1. So negative 36 plus 1 is negative 35 over root 10y plus 25. That's the easiest step. It's basically moving everything to one side. In the next step, we are going to rotate counterclockwise or rotate this clockwise. So again, I'm going to assume these are primes, and I would say x prime is 1 over root 10x plus 3 over root 10y, and the y prime becomes negative 3 over root 10x plus 1 over root 10y. Notice what we did. Here it was negative positive, here it becomes positive negative. Counterclockwise, clockwise. Okay. I'm going to substitute again. This is the toughest step, really, the longest one. I have 1/5, and then the x squared becomes 1 over root 10x plus 3 over root 10y squared plus 6/5 times x times y. Oh, I'm sorry, I forgot to write y square here. I know some of you were screaming, where is the y square? But I'm an old man, so I couldn't hear you. I'm sorry. And then I have plus 9/5, and then the y squared becomes negative 3 over root 10x plus 1 over root 10y quantity squared. And then I have minus 15 over root 10x, which is 1 over root 10x plus 3 over root 10y. You have to be very careful here. Minus 35 over root 10 times y, which is negative 3 over root 10x plus 1 over root 10y. And finally, plus 25 equals 0. And then we will expand. Some would say, oh my God, this is too much. Yeah, but we are going to do it in an easier way. I know there is a term in x squared, a term in xy, a term in y squared, x, y, and a constant, like a generic conic section. So let's take the x squared coefficients first. This guy is squared, so it's 1/10 times 1/5 is 1 over 50. I come here, there is an x and an x. When you multiply them, you get negative 3 over 10 times 5, negative 3 over 15 times 18, okay? So negative 3 times 6, I get negative 18 over 50. I know you can simplify it, but since this already has a denominator of 50, so let's leave everything 50, meaning this would be minus 18 over 50. And then here I have another x squared. When I square that, I get 9 over 10 times 9 over 5, which is 81 over 50, x squared. Wasn't that bad. Let's look the xy plus. Here the xy, when you square, you get twice the first times the second. So 2 times 3 over 10 is 3/5 times 1/5 is 3 over 25. And then here, I have this term times that and this term times that. Both of them will give me xy. So I have 1/10 minus 9/10 is negative 8/10 or negative 4/5 times 6 over 5, negative 4. That would be minus 24 over 25. Again, I have the same denominator, so I'm not going to, in fact, I couldn't simplify, but even if it were simplified, I wouldn't do anything. Here I have a term in xy, which is twice the first times the second, which is negative 6 over 10 or negative 3 over 5 times 9, so negative 27 over 25 xy. Okay? Then I'm going to look at the y square. I have 9/10 times 5, so 9 over 50. Here I multiply this by that, I get 3 over 10 times 6 over 5, so plus 18 over 50. Again, I'm not going to simplify. And finally, I have 1/10 times 9/5 is 9 over 50. y squared. Let's move to the x. Of course, the first three don't have any x's. I have negative 15 over 10 plus 105 over 10. 105 minus 15 is 90. 90 over 10 is 9. So I get plus 9x. I hope I did that correct. Negative times negative is positive. This is 105. Negative times positive is negative 15. 105 minus 15 is 90 over 10 is 9. Yeah. Let's do the y. Negative 45 over 10 minus 35 over 10. That's negative 80 over 10. So minus 8y plus 25 equals 0. Let's just add everything. 81 and 1, 82. 82 minus 18 is 64. Simplify by 2, you get 32 over 25x squared. Negative 51 plus 3 is negative 48 over 25xy. 9 and 9, 18, and 18, 36 over 2 is 18 over 25y squared plus 9x minus 8y plus 25 equals 0. At this point, I can make a quick check. In fact, I could have made it here, but no, better here because we already rotated and changed the y meaning and so on and rotated back. Something that maybe I didn't mention in the previous lecture, but it would have been better to show it there. It's really the same thing. It's not going to be any different to show it here. We said the generic, like this guy, a generic conic section is ax squared plus bx plus xy, I'm sorry, plus cy squared plus dx plus ey plus f equals 0. We told you that if A equals C, that's a circle. If it's not equal but same sign, it's ellipse and so on and so forth. But since you already, now we have XY. We didn't have XYs there because it was before rotation. So how would we know what a conic section that is? Remember when you solved the quadratic equation, you used something called the discriminant? When you said negative b plus or minus square root of the quantity under the square root, which is b squared minus 4ac. This one allows you to know what type. Wow, interesting, right? It will tell you what type of conic section is. If this value is negative, you get either an ellipse or a circle. Of course, you would know if A and C have the same magnitude, same sign, and same coefficient, then that's a circle. If they have the same sign but different coefficients, then it's an ellipse. Okay, so if they are the same, it's circle. If they are different, it's an ellipse. If that, I'm sorry, I said if this is greater than 0. No, I'm sorry, if that's less than 0. Why am I confused? If it's equal 0, then that becomes a parabola. That's the case we have. And if that b squared minus 4ac is greater than 0, you get a hyperbola. So let's check. Forget about the denominators because they don't matter. Take the negative 48. Negative 48 squared is 2304. And 4 times A times C is 2304. Yes, meaning b squared minus 4ac equals 0. And that is a parabola. So I know that at least sign-wise, I didn't make mistakes. This is really a parabola. But then we may have another way to check the final answer. Because step number 5, I'm going to substitute y plus 2 because I'm going to reduce it or lower it 2 units. Lowering meaning every y would become y plus 2. The first equation doesn't, the first term doesn't change. The second one would be negative 48 over 25 x times y plus 2 plus 18 over 25 y plus 2 square plus 9x minus 8 y plus 2 plus 25 equals 0. And then I'm going to expand. The x squared, the xy, and the y squared will not change. Because you don't have anything, you added 2, so there is no squares in the matter, right? Or cross product. However, what will change are the x, the y, and the constant. Let's see the x. The x so far here, it doesn't, here, you see, you have negative 48 over 25 xy, which is this, but then you have negative 98 over 25x, negative 48 times 2 times x. This one doesn't have x's. This is plus 9x. And then how about the y? There is no change in the y. Here I have 4y. When you expand that, you get y squared plus 4y plus 4. So the y have a coefficient of 4 times 18 is 72 over 25. And then here, negative 8 times 2 is, no, I'm sorry, negative 8y, so minus 8y. And then the constants. I said 98 is 96, right? 48 times 2. I can do mental math. You can help me after that. Okay, let's look at the constants. I don't have any constants here. Here I have, because y plus 2 squared will give me 4. 4 times 18 is 72 over 25. Negative 8 times 2 is negative 16, and then plus 25 equals 0. Okay, it seems like everything will have a denominator of 25. So maybe as we go, we multiply by 25 and see what we get. So this would be 32x squared. Notice you can multiply right and left by the same number and you didn't change the equation, right? So that's why I'm going to multiply by 25, because why would I leave fractions as the coefficients? So that would be 32 minus 48xy plus 18y squared. Now, the 9, you see what I can do? Forget about the 25. I'm going to say 9 times 25 minus 96. So 9, oh, what is this calculator? It's horrible. 9 times 25 minus 96 is 129. So plus 129x. 72 minus 200, because, or minus 8 times 25. I get negative 128y. And then 25 minus 16 is 9. 9 times 25 plus 72. Plus 72 is 297 equals 0. So I'm saying this is the final equation of the parabola. And you say, okay, we know it's a parabola, but how do we know it's correct answer? I say the easiest way, maybe if you want to check your answer, it may take some time. I'm going to pick a point on the original parabola. I think the easiest thing is to set x equals 3, right? If I say x is 3, then this thing would be 0 and y would be 5. That's basically the vertex. So we are going to apply the same 5 steps, but of course here we are going to rotate clockwise first, change, and then counterclockwise, because that's a point, not an equation. Be careful here. And then at the end of the day, we end up with some numbers. I'm going to apply them here and see if I get 0. If I don't, then I did a mistake. If I get a 0, we would be lucky. With all these fractions, it's like, I'm not sure. Step number 1, I raise everything by 2 units, so this number would be 37. Quickly, that's a check, okay? So even if you don't follow me, you can review it, you can watch it again and see it, but I don't want to waste your time. Here I'm going to say the new x would be 1 over root 10 times 3 plus, not minus, plus 3 over root 10 times 7. And the y would be negative 3 over root 10 times 3 plus 1 over root 10 times 7. So I will get 3 and 21. This is 24 over root 10, right? And this is negative 9 plus 7 is negative 2 over root 10. Step number 3, those would become 24 over root 10 and 2 over root 10 because I'm going to change the y. I hope I didn't do anything wrong so far. We'll see. Step number 4, I'm going to rotate counterclockwise. So I'm going to say the new x equals 1 over root 10 times 24 over root 10 minus 3 over root 10 times 2 over root 10. And the y becomes 3 over root 10 times 24 over root 10 plus 1 over root 10 times 2 over root 10 equals 24 minus 6 is 18. 18 over 10 is 1.8. 72 plus 2 is 74 over 10 is 7.4. And finally, remember here we added 2 to the y, so we subtract 2 from the y, you get 1.8 and 5.4. If this point turns out to be on that, we check the answer. If not, I will cancel the video and redo the problem. Yes, of course. I'm not wasting your time, and then, you get the wrong answer. So 32 times 1.8 square minus 48 times x times y. It doesn't seem that, anyway, 18 plus 18 times 5.4 square. Oh my God, plus 129. Everything is positive and positive. I don't know how you get 0. Times 1.8 minus 128 times 5.4. If I get negative, how? If I get negative 297, I should be fine. Yes! Negative 297. So, and I add 297. So, oh my God, it was correct. I was a little hesitant to do that, but I said I have to check. And as I said, if it were wrong, I would have deleted the video and redo it. I'm not kidding you. Anyway, I hope you understood what we did when we deal with a function, like what we did last time. If it's a straight line, if it's an ellipse, hyperbola, parabola, you do in the rotation, you do backwards. So if you want to rotate clockwise, you apply the counterclockwise rotation. And when you want to go counterclockwise, you apply the clockwise rotation. After that, you just add the numbers and subtract the numbers or change the sign of y. If we're rotating about the y, we would have changed the signs of x, and we could get. There is another check that you can do. It's telling you that if you have an inclined parabola like this one, then the angle between the parabola and the x-axis, it's cotan 2 theta, twice the angle between the parabola and the x-axis is a minus c over b. Of course, the calculators don't have cotan, but you know that the cotan of an angle is the tan of its complement. In fact, the co stands for complement of tan, cotan, the complement of the tan. So the tan 2 theta would be b over a minus c. So you get this angle divided by 2. So you can find the angle, first of all, between the original parabola that has its axis as the y-axis and this line has a slope of 3, you can use the calculator and find the tangent of 3, subtract it from 90, you can find the angle between these two things. And then for the new parabola, you can find the angle that is here, you subtract it from 90 and see if that angle is twice as much as that. Because if it is, it means you really reflected it over the line. This angle has to equal that angle. Again, we don't have time for that, but since we were lucky and this thing turns out on the new parabola, we know our answer is correct. Okay, so you really have three things. You can check first to know what type of conic section you ended up with by applying the b square minus 4ac and make sure it's 0. You can pick an easy point on the original parabola, apply all these 5 steps to it, and see if the resulting point fits the new parabola, or you can use the cotan of 2 theta. If you're becoming a mechanical engineer, you will get a very common or similar thing here when you learn about principal axes, but that's a topic for another day. Thank you very much for your time. I hope you enjoy it, and I wish to see you soon. Have a nice day.